Welcome back. Objective 4.5, modifying enterprise capabilities to enhance security. This is the broadest objective in Domain 4. Firewalls, IDS and IPS, web filters, OS security, secure protocols, email security, FIM, DLP, NAC, EDR, XDR, UBA. The whole enterprise toolbox. The exam will hand you a scenario and ask which tool fits the job. We are going to walk every tool, rank them by what actually breaks first, and tag the trap on each one. Picture this, 3 a.m. A retailer's SOC wakes up to an active C2 beacon from an internal workstation calling out to a domain registered 6 hours earlier. The analyst pulls the firewall logs. The traffic was allowed. Why? Because the firewall rule said permit any out on HTTPS and the destination was a freshly registered domain on a legitimate cloud provider. The firewall did its job. The firewall just was not the right tool. A web filter with reputation scoring would have blocked the request. A DNS filter would have blocked the lookup. An IPS with C2 signatures would have flagged the beacon pattern. An EDR with behavioral detection would have caught the spawn process. They had none of those. They had a firewall. The cost of that gap was $4 million in incident response. The firewall rule that should have caught it was every rule we are about to talk about. Different tools catch different threats. Defense in depth is not a slogan, it is the only architecture that works. That is the entire lesson of 4.5. Start with firewalls. The basics first. A firewall is an ordered list of permit and deny rules, ACLs, based on source IP, destination IP, port, protocol. Rules are evaluated top-down and the first match wins, which is why rule ordering matters. Every firewall has an implicit deny at the end of the rule set. If no rule matches, traffic is denied. That implicit deny is the safety net. 2 evaluation modes. Stateful inspection. Tracks the state of connections, allows return traffic automatically once a session is established. The firewall remembers that you initiated the connection and lets the response back without an explicit return rule. Stateless filtering. Evaluates each packet independently. No session memory. You have to permit return traffic explicitly. Stateful is the modern default. Stateless is older and lives mostly in switch ACLs and certain cloud network ACLs. AWS network ACLs are stateless. AWS security groups are stateful, and the exam will quiz that distinction. The screen subnet, also called the DMZ, is the network zone between the internet and the internal network where you host public-facing servers. The firewall sits between the DMZ and both the internet and the internal network. 2 firewalls in the screen subnet design, one between the internet and the DMZ, one between the DMZ and the internal network. Then the firewall flavors ranked by capability. Number 1, modern default. NGFW, next generation firewall, adds application awareness so it can identify Facebook traffic regardless of port, user identity so it can apply rules per Active Directory user, not just per IP, SSL inspection, so it can decrypt and inspect encrypted traffic and integrated IPS. Number 2, WAF, Web Application Firewall, specifically protects web apps, inspects HTTP and HTTPS, blocks SQLI and XSS, understands the application layer, sits in front of the web application. Number 3, UTM, Unified Threat Management. All in one device, firewall plus IPS plus antivirus plus VPN plus web filter, popular in mid-market because it is one device and one license. The exam will distinguish each. NGFW for general perimeter, WAF for web app protection, UTM for small to mid-size environments that want one box. A network firewall does not understand application logic. A WAF does. That is why WAF sit in front of the web app and NGFW sit at the perimeter. IDS versus IPS, the single most tested distinction in 4.5. IDS, Intrusion Detection System, detects and alerts. Out of band on a tap or spam port, traffic does not pass through it, the IDS sees a copy. Detective control. False positives generate alert noise but do not impact traffic, which is why IDS is safer to deploy aggressively. IPS, Intrusion Prevention System, detects, alerts, and blocks. Inline, traffic must pass through it. Preventive control. False positives drop legitimate traffic, which is worse than alert noise. A misfiring IPS can take down production. The exam mantra, IDS detects, IPS prevents. The deployment trade-off, IPS is more powerful but more dangerous. IDS is safer but cannot stop the attack in real time. Detection methods inside both IDS and IPS. 4 flavors. Signature-based, matches known attack patterns from a database of rules. Low false positives, blind to 0 days, depends on signature update cadence. Snort and Suricata are the open source signature engines you will see referenced. Anomaly-based, deviates from a baseline. Detects 0 days because a new attack will look anomalous, but higher false positives because so do new legitimate use cases. Behavior-based, analyzes patterns over time, applied to endpoints. Heuristic, rules-based plus machine learning, good for new variants of known threats, complex tuning. And deployment scope, NIDS or NIPS monitors network traffic. HIDS or HIPS monitors a single host. Network-based for the network, host-based for the endpoint. Web filters, 6 knobs. Agent-based, software on the device. Filters regardless of location, the right tool for remote workers and laptops that leave the office. Centralized proxy, all traffic routes through a proxy server, one control point, easier to manage on a campus. URL scanning, examine destination URLs against block lists, drop matches before the connection happens. Content categorization, classify by category like social media or gambling or news. Allow or block by category, lets HR block adult content without naming every site. Block rules, explicit rules for specific domains, IPs, or URL patterns. Reputation scoring, sites scored 1 to 100 based on threat intel, low score equals blocked. New domains, freshly registered domains, domains with bad reputation get blocked automatically. And DNS filtering, block at DNS resolution before the TCP handshake even starts. The simplest form of web filtering, Cisco Umbrella and Cloudflare Gateway are the names. DNS filtering catches the C2 beacon from our cold open the moment the malware tries to resolve the new domain. OS security. 2 systems the exam will name. Group policy objects on Windows, the policy container in Active Directory that enforces screen lock, password policies, software restrictions, USB disabling, firewall settings, scheduled tasks, drive mappings. Default domain policy applies to everyone in the domain. OU-level GPOs apply to specific organizational units, like a finance OU with stricter password rules than the rest of the company. Group policy preferences are settings users can override. They set defaults, not enforce them. The exam will distinguish between group policy settings, which enforce, and group policy preferences, which set defaults. And SELinux on Linux, mandatory access control built into the kernel. Every process and file has a security context, a label like HTTPD_T for the Apache daemon, and the policy says HTTPD_T can read this and not that. Access decisions based on policy, not just file permissions, so even root cannot bypass SELinux when it is enforcing. Modes, enforcing, where policies enforce, permissive, where the kernel logs violations but does not block them, and disabled. SELinux is the default in Red Hat and CentOS, and it is the differentiator for government and DoD Linux deployments. The other option in the same space is AppArmor, default on Ubuntu, similar idea, profile-based instead of label-based. Secure protocols, memorize these like you memorize port numbers. SSH replaces Telnet for encrypted remote administration. Port 22. TLS 1.2 and 1.3 for encrypted transport replaces SSL, which is broken and deprecated. Port 443 for HTTPS. HTTPS is HTTP over TLS, port 443. IPsec encrypts IP packets used in VPNs, operates at the network layer. SNMPv3 for encrypted device management, ports 161 and 162. The pattern across all of these, old plaintext protocol gets replaced by encrypted version. The encrypted version usually adds an S or a TLS aware variant. File transfer secure protocols. SFTP uses SSH port 22. FTPS uses TLS port 990 for implicit TLS, port 21 for explicit TLS. SCP uses SSH port 22. The classic exam trap, SFTP and FTPS sound similar and are completely different. SFTP is SSH based, FTPS is TLS based. Directory and email. LDAP for directory lookups, port 389, unencrypted. LDAPS for LDAP over TLS, port 636, encrypted. S/MIME for email encryption and digital signing. SRTP for secure real-time transport protocol, encrypts voice over IP DNS, security, DNS-SEC, cryptographically signs DNS records to prevent spoofing, DNS over HTTPS called DOH, DNS over TLS called DOT on port 853. IPsec components because the exam loves these. Two protocols inside IPsec. AH authentication header provides integrity and authentication, no encryption. ESP encapsulating security payload provides integrity, authentication, and encryption. Use ESP for confidentiality, full stop. Two modes. Transport mode encrypts only the payload. The IP header stays intact. Used host to host. Tunnel mode encrypts the entire original packet and adds a new IP header. Used in site-to-site VPNs. The exam mantra, ESP encrypts, AH does not. Tunnel mode is for VPN. Email security, 3 DNS-based standards plus 1 gateway. SPF, Sender Policy Framework. DNS TXT record listing authorized IP ranges that can send email for the domain. Receiving servers check SPF, drop or flag mail from unauthorized senders. DKIM, domain keys, identified mail, private key signs. The outgoing message, public key in DNS, verifies the signature, ensures the message was not modified in transit. DMARC, domain-based message authentication, reporting, and conformance. DNS record that says what to do when SPF or DKIM fail. 3 policies, none for monitor only, quarantine for spam folder, reject for outright drop. DMARC also generates aggregate reports back to the domain owner so you can see who is sending mail claiming to be you. Secure email gateway, scans inbound and outbound for spam, phishing, malware, DLP enforcement, attachment sandboxing. And S/MIME for end-to-end email encryption and signing using certificates requires PKI infrastructure. The exam mantra, SPF authorizes senders, DKIM signs messages, DMARC ties them together with policy. FIM, file integrity monitoring. Tripwire is the classic example, and the exam will use that name. Other tools, OSEC, AIDE, Wazoo. FIM creates hash values of files, alerts when the hash changes. Catches malware installation, config changes, unauthorized modifications to critical files. Apply FIM to system binaries, web routes, configuration directories, anything that should not change between releases. The first time you deploy FIM, expect noise as you discover all the legitimate updates that change files in places you forgot about. Tune the policy, then keep tuning it. DLP revisited from 4.4, 3 deployment modes. Network DLP at the perimeter inspects email attachments and web uploads. Endpoint DLP on the device monitors, USB and print and clipboard. Cloud DLP inside SaaS applications watches sharing and downloads. The exam will pick a scenario and ask which mode fits. Outbound email exfiltration is network DLP. USB exfiltration is endpoint DLP. Sharing a sensitive doc to an external Google Drive is Cloud DLP. NAC, Network Access Control. Controls which devices can connect to the network based on compliance and identity. 802.1x is the port-based version. The supplicant on the device authenticates to the authenticator on the switch via RADIUS to the authentication server, and only then does the port go live. Health checks verify the device has antivirus, updated patches, correct config before granting access. Non-compliant devices end up in a remediation VLAN until they are fixed, patched up, antivirus signatures updated, then re-evaluated. NAC agents can be persistent, always running or dissolvable, downloaded for the session and discarded after. The exam will ask which tool authenticates devices before they get a working port. Answer: NAC with 802.1x. EDR and XDR. EDR is endpoint detection and response, behavioral detection, threat hunting, automated response, telemetry collection from endpoints. The big EDR names: CrowdStrike Falcon, SentinelOne, Microsoft Defender for endpoint, Carbon Black. XDR is extended detection and response. Correlates telemetry across endpoint, network, cloud, and email in a single console, so you can see a phishing email arrive, the user click, the process spawn, the network connection out, all in one timeline. EDR is the evolution of antivirus. XDR is the evolution of EDR. Both feed SIEM, or in some architectures, XDR replaces parts of SIEM for security-specific use cases. The difference between EDR and XDR is scope. EDR is endpoint only, XDR is everything. UBA, User Behavior Analytics, establishes baselines of normal user behavior, alerts on deviations, unusual login times, accessing unusual files, large data transfers, sudden spike in access to sensitive systems. Primary use case: insider threats and compromised accounts, because both look like a real user behaving in unusual ways. UEBA is UBA extended to devices and services as well as users. The exam mantra: UBA detects insider threats by spotting deviations from the baseline. The classic UBA catch: longtime employees suddenly downloading every file on a project they have never touched, 2 days before they put in their notice. The activity itself is allowed, the pattern is not normal. Quick recap, organized by which tool catches what. Network perimeter: NGFW, UTM for small environments, WAF in front of web apps. Network internal: NIDS, NIPS, NAC with 802.1x. Web access control: web filter, agent base for remote workers, DNS filtering for the simplest case. Endpoint protection: EDR for behavior, XDR for cross-domain correlation, FIM for file integrity, host firewall for local rules. OS hardening: GPOs for Windows, SELinux for Linux. Encryption protocols: SSH for management, TLS for transport, IPsec for VPN, LDAPS for directory, S/MIME for email. Email defense: SPF authorizes, DKIM, signs, DMARC enforces. Secure gateway scans. Data: DLP for exfiltration, classification labels for context. Identity: UBA for behavioral anomalies. Each tool has a job. The exam will hand you a scenario and ask which job and which tool. Match them. That is Objective 4.5. The retailer in our cold open had one of these tools and needed 7. Defense in depth means stacking the tools so the gaps in any single layer are caught by the next. The firewall did not catch the C2 beacon. A web filter would have. A DNS filter would have. An IPS would have, an EDR would have. Build the stack. The exam will not ask you to deploy all of these in a single answer. The exam will ask which one fits a specific gap. Read the scenario, find the layer, name the tool. Next up, Objective 4.6, Identity and Access Management. We are going to talk about the overprivileged service account that became root. See you there.